Hello and welcome everyone in the value added course on CSV05 Internet of Things. I am Salia Mariam and I will give you a lecture on Arduino and overview. In this slide, we will learn about what is Arduino, what Arduino can do, and why only Arduino when many of the microprocessor and microcontroller are present there. And after that, we will see that what's the difference between microprocessor versus microcontroller. Then we will explore the Arduino boards and will understand the whole anatomy of the board. Then we will move on to Arduino IDE. Here we will understand how we can install this Arduino IDE on different platforms like Windows, Linux and Mac OS. In Arduino API, we will learn the whole programming structure of the Arduino program, that how you can program and load your program on your firmware. And this programming is like C programming only, and it's very easy to use. In state of the art, you will learn that how Arduino IoT Cloud is giving a good application to Arduino based project. Smart home automation is one of the popular state of art of Arduino, and lastly we will see some more Arduino based project that will surely motivate you to use this Arduino. And end note, we will summarize our lecture. By the end of this lecture, you will know that what is Arduino, how the programming is done, how you can implement your application on Arduino. And in the next lecture, we will have a hands-on on Arduino. The course prerequisites for this is a basic understanding of computer. One should know that what is computer, how to use this computer. Some C programming background is preferred as the programming structure of Arduino is very much similar to C. It's very easy and it also uses the C libraries. Some basic knowledge of electrical and electronic component and circuit is preferred. This is a desirable thing, as one should know that what type of embedded system are there. One should have a good, I can say, good knowledge of sensor and actuators, all these things. So these are the desirable condition. One should not be very much worried if any of these knowledge one does not have. We will learn slowly here only. So let's just start with Arduino. Arduino is an open source electronic platform. Before knowing that what is Arduino, let us know that how this Arduino started. Arduino was started as a master thesis by some student. They were building a prototyping tool. So later they made many changes came, and this Arduino board became one of the microcontroller based platform to do the programming and to actuate these devices. At this time, Arduino company is in Italy, and it gives the microcontroller board. There are many boards. There is a whole family of Arduino exists there, but here we will mainly focus on Arduino Uno. As I have told you, that it was developed as an easy tool for fast prototyping. Later, Arduino board started changing to adapt new needs and challenges, differentiating its offer from simple 8-bit boards to product for IoT applicables. Many times we get confused with Arduino board that it is a microcontroller. No, it's not a microcontroller. It's a microcontroller based board. It have the microcontroller, but it's not a microcontroller. In a further section, we will learn the difference between the microcontroller and microprocessor, and also we will see that how this board of Arduino will look. Okay, it is able to read inputs like light on a sensor, a finger on a button, or a Twitter message, and it also turns its input into the output by activating a motor, turning on a LED, publishing something online. There are variety of examples that this Arduino can do. It's what it can do is not limit up to here. You can add more programming of your own. You can add your idea, and you can automate your idea to make a complex application using these Arduino board. These are really wonders. To tell your board what to do, we need to do the Arduino programming. Yes, small programming that are not so difficult, very easy programming are there that you can do using the Arduino software IDE. Further, we will see that on this Arduino family here, I have put some boards from the Arduino family. These are not all. In this session, we will focus on the Arduino Uno board only because it is the simple and cheaper and easy to use. But the ability of Arduino does not constrain to this board only. There are other boards also, like you can see this flower like lily pad. This is a flat board lily pad which can be used for e-textile. It can be seen in the clothing, and using the conducting thread it can be used to place to work, and it is washable also, and it's very much used. The other one is the Arduino Mega board. Arduino Mega board is one of the customized board which have the ability to take the multiple input output. It as it have multiple pins, means 54 pins you can see here are there, out of which 14 are the analog input pin, and it have the power jack also, and it's used for the bigger project as the name suggests. Another one is this red board. Red board was designed to take all the Arduino feature all in one. You can say that this is the customized board where you can get the mini B cable, USB also, and other features also in one board only. But it's not cheaper. It's little expensive. So generally, what the beginners use, even the advanced learner also use, is the Arduino Uno R3. One more board among this Arduino family is popular is Arduino Leonardo. This is not here, but it can even emulate the keyboard of a computer and mouse also. So they have very extraneous features. Let's move to next slide. When many boards are present in the market other than Arduino, then why we are only considering Arduino boards? First of all, it's open source. Open source means it's free to use. It's open for all, easy to use, and there is no pricing thing behind it. Easy prototyping platform. Very simple ideas are there. When we will do that online, use the online simulator in further lecture, then you will see that how simply we can use it. We can just drag and drop the code. Even in Arduino IoT Cloud, you will get the code already there, means lesser approach you need to do the coding. All you need is to automate your idea, whatever the idea of building any electronic component or device, or connecting to more devices, whatever idea you have to automate, that you can use here, and you can make a prototype of you. Easy to use for beginner yet flexible. For beginners, it's very easy to use. There is no time constraint, there is no knowledge constraint. Once you open the Arduino, step by step you will learn very gradually. It's flexible also, as it gives the it's scalable, and many new features can be integrated into that, and the existing designs can be improvised by the advanced learner. Inexpensive, yes, it's cheap. The clone version you can get around 500, and I think that original you can get up to 1500. It's not so expensive board, so it's inexpensive. This is also one of the reason that why Arduino is being preferred too much. Arduino IDE uses a simplified version of C++ languages. The programming structure of Arduino is very simple. All you need to take the block, code your own. If you need some any other function, you need to add the function block as you do in C, and it's ready to go. I will say that is more simplified than C language. Key tool to learn new things. Yes, when the hobbyist and the people who are keen learners, who want to automate and want to learn new things, so this is the place where you can find very where many of the projects are also existing on online sites like Instructables and other make project. Even on the website of Arduino itself, many projects are there, tutorials are there where you can learn new things and explore the whole world of Arduino. Best tool for automating, as I have told you, you can automate your idea here. You can automate your idea of automating any components and doing anything using Arduino. What Arduino can do. Let's see that what is the ability of an Arduino board. It's great for prototyping ideas because it can assess multiple things, like it can assess the GSM, it can control the triggers, it can assess the LEDs, all these things, access to multiple input output. It have both analog pins and digital pins, even it have inbuilt ADA converter also there. It can drive motors, turn on lights, trigger controls. It can sense the object moving from one place to another. It can give the input to anything. Even it can tweak what I have told you. Low power requirement, only 0 to 5 volt power it needed. Flexible or open source. Flexible, it can be improvised, means if you have designed some application using the Arduino board, then that application can be improvised as it is open source also. So it's easy to use, it's not so hard to, or there's no financial constraint. Can tweet, yes it does. I, I have an example that one, there is a video on Instructable where it says so that one man tweet to his coffee pot that I need a coffee. And then he tweet that stop it when it done. And when he reaches his place, using that tweet, the Arduino board have made the coffee. Using the coffee pot, and the instruction from the laptop was going through the Arduino and the coffee was prepared. Yes, it was done. So these all things we have seen that what Arduino can do. Now we will see if the what's the difference between microprocessor versus microcontroller. Why we are studying this thing? Because many times students get confused that Arduino is a microcontroller or microprocessor. First of all, Arduino is not a microcontroller. Arduino is a microcontroller based platform, based board, which have the microcontroller, which is not a microcontroller. Okay. Another thing is it's not a microprocessor. Why? Because it has its own flash memory, it has its own peripheral input output devices, it have its own microcontroller on it, all these things. So microprocessor is an integrated chip which has only CPU inside them. It have only processing power. It can do some specific task like only processing thing. It cannot, we cannot program, do a, give it a whole program or a set of instruction and it will process that. No, this doesn't happen in microprocessor. They don't have a RAM, they don't have a ROM and other path to make it functional. We use other things, these things externally. And microprocessor are also cheaper, are expensive, sorry, microprocessor are expensive than microcontroller. Microcontroller is a low cost computer on a single integrated circuit. Why we are calling it a low cost computer? Because first of all it is very, not very costly. Another thing is that it have its own CPU, it have its own RAM, it have its own peripheral input output ports. So it makes a whole computer there. We can instruct it to perform a dedicated task or any specific task. Microcontroller basically found in the embedded system, like I can give you example of the washing machine in your home, microwave in your home, all these are having microcontroller. But microprocessor you will find in your desktop, your laptop, your mobile phone, in these things. For your better understanding here, you can see that micro block diagram of microprocessor and microcontroller. In microprocessor, you can clearly see that only the processing unit Central processing unit is inside the microprocessor. Other peripheral devices in the memory unit are externally linked to it. While in microcontroller block diagram, you can easily see that it has its own RAM, it has own ROM, it has its own serial communication port and input output ports, and timer means clock is there. So we can I can also tell you that in 1971 only the first microprocessor of Intel 404 was also built, and in 1971 only first microcontroller by Gary Moore was built. And apart from these things, microprocessor is called the heart of computer, while microcontroller is called the heart of embedded system, because microprocessor does the processing task, means it can do repeatable cycle of instruction very frequently, like we have studied the whole subject of microprocessor, where it fetch the instruction, decode the instruction, execute the instruction, all these things. But the microcontroller do task more than this: fetch, decode and execute operation cycles. So this was all about microprocessor and microcontroller. In nutshell, you can say that microprocessor does the processing task, do the repeatable cycle of fetch, decode and execute, while microcontroller does the specific task assigned to it. Microprocessor you can find in the your PC, your laptop, your desktop, while microcontroller you will find in the firmware like washing machine, your induction cooker, induction, even your automatic machines like refrigerator, you can say all these things. Microprocessor is having a complex chip, but microcontroller is not so complex as all the things are inside it only. Okay. Arduino board. Now we will explore the Arduino board. It is a PCB mounted Arduino board having the 880 mega 328p microcontroller on it. It have its own USB connector, a DC barrel jack you can see to give the power. It can take 0 to 5-volt power supply. It has own digital input output pin along with analog input pins. It have a TTL USB TTL converter. It is used for embedded communication device for communication. This board you can use to perform simple tasks. You can do simple programming and assign some more functions to it, like mathematical computation or some logical work like these things. So let's start with every component on this board, and we will see one by one each and every component. First of all, this is a Arduino block diagram in front of you. In the above these pins and the lower pins, these pins are the input output ports where you can connect the any peripheral devices, like you need to connect the LEDs or some potentiometer for your purpose, then you can connect here. Here is the USB port through which you can connect your laptop for the communication with the Arduino board, for loading your program on the Arduino board, all these things, and sometime it is used for power also. This DC input is for power supply to this. Here the power circuit is there, and this USB TTL is to communicate with this embedded system, and here resides the microcontroller 80 mega 328p. See, this is a basic Arduino block diagram. Capabilities of Arduino board doesn't limit here only. There are many other boards with many more features than this, but here we are understanding this simple Arduino Uno R34. Uno word itself means it's the first version of Arduino that we are studying here. So let's see one by one. First we will see the USB port. So here is the USB connector port. This can be used for two purposes. One purpose is to load your program on the Arduino board, and the other purpose is to give power supply. Sometimes we give the power supply using the USB connector. Now, next we will see this ICSP pin. Here are the 6 pins and here are the 6 pins. These 6 pins are for the ATmega 328p controlling, and these 6 pins are dedicated to ATmega 16U controller. This is this is an embedded microcontroller on this board, and our main microcontroller is controlled by these pins. Okay. Here you can see the reset button. In reset button, what happened when the reset button is pushed, then the reset pin is touched with the ground and the whole settings of the Arduino is being reset. A ATmega 328p microcontroller, which is the heart of this Arduino board, it gets the clock cycle with, there is a MCU, there is MCU right here. Sorry, 16 megahertz micro resistor lies here, which give the clock cycle to this through which it works. Okay. Is it clear? Now we will see next thing is this DC barrel jack. This DC barrel jack is to give the power supply. Our microprocessor, our Arduino board takes the power supply of 0 to 5 volt only. In this only, I was talking earlier about 16 megahertz resonator. This is here, and this gives the clock cycle to this ATmega 328p microcontroller on which it works. And next is, for a microcontroller to work, it needs the clock cycle. As I have told you that for ATmega 328p there is a 16 megahertz resonator that gives the clock cycle to it. Similarly, for this ATmega 16U also, there is a crystal oscillator which gives the clock cycle to it. So the clock cycle, actually what happened, that it decide that speed with which the microcontroller operates. Speed here we refer to the number of instruction executed per cycle. Okay. Now the next thing is the power path control. Actually, if you see very clearly, it's not shown here, but yeah, it's marked here. This LM358, this thing, this actually control the power input. When we give the power input with this jack barrel, then it closes the input pin from this USB connector. So basically it controls how the power input is going in the circuit board. Okay, is it clear? Now next thing is analog input and digital input. Our Arduino board have these 14 pins digital input output pin and this 6-bit analog input pins. You can also use this analog input pin as a digital input output pin. It actually acts as a ADC, analog to digital converter. It simply take the value and sample and quantize in over the UNO board. Okay. Our board, the power input from DC barrel jack receive the 7 to 12 volt of voltage, but our board support only 5 volt of current. So to regulate this voltage, there are two voltage regulator on our board, 5 volt regulator and 3.3 volt regulator. 5 volt regulator is for this 8 mega microcontroller to regulate, and for the 8 mega 16 unit, this 3.3 volt regulator is there. Okay. On our board we have four LEDs. One is this power LED, which is here, which shows that whether it is on or off. The other is this RX and TX LEDs, which shows whenever it actually flickers when there is any RX or TX activities are there. And one is this built-in LED, which is actually connected to pin number 13. Okay, this pin number 13, so it can be used as an indicator like that whether your Arduino board is working properly or not. So these are the four status LEDs which show the status of the boards. So let's quickly revise all the components of our board. First one is the USB port. USB port have can be used for the two purpose. One is for the communication through the any other device like laptop or mobile, and other is for the power input. Next one is the ISCP pins. We have seen that on 2 points there are six ISCP pins for both the microcontroller, one for 80 mega 328p microcontroller, one for 80 mega 80 U's mega U microcontroller. Next, we have seen the reset button. Reset button was to reset our chip. USB TTL interface chip was simply used for communication with the computer for our computer. Means that it is a simply USB TTL connector or converter, you can say, that makes the communication easy between the Arduino board and the computer system. Circuit oscillator and for giving the clock cycle to our microcontroller. Another one is power path control. We have seen that LM328 chip there on the board, which act as a power, which control the power path when there is input from our jack barrel, then it of the input from the USB port. Board for installing, you can install this Arduino IDE 2.0 on Windows, Macs, and Linux by clicking on this Arduino software. What you need to go is go to this page of Arduino in this. So for downloading Arduino IDE, what you need to go is go to this page of Arduino. In this you will get page on Arduino main website, the software page, where you will see this tutorial also. So let's start with the installation work. For installing, you can install this Arduino IDE 2.0 on Windows, Macs, and Linux by clicking on this Arduino software page, which will redirect you to this page where you can find the future version of Arduino IDE. From here, you can select whichever your Windows is there. Suppose you have Windows, then click on Windows. Mac OS, you click on Mac OS. And if you have Linux, then you will click on Linux. Okay. Here also this download option. So as soon as you will click on it, this will download. So let me show you by clicking. Just you need to click on just download and it will start downloading. Okay. So let's see in a nutshell that how this is going to be. So first of all, we will go through that Windows installation. After installing, you will get this file in your downloads folder, and when you will click on the download on this file, then these windows will come in which you have to simply do the next, and this will get installed and you're good to go. Now what you need is your hardware. Your software is ready. Connect it with your laptop, do the programming and upload on this. Next is Mac OS. On Mac OS, what you need to do is keep this downloaded file in your application folder and you are set. In Linux, there are some tasks that you need to take care of, that you need to extract your file in Linux by right click on it on the downloaded file, and then you need to open that folder where you have extracted all these content, and by doing the right click you will open the terminal, and there you will type this /Arduino IDE. Okay. Dot is used for the current, it denotes the current directory. It will launch your IDE editor, and this was all about the installation. So these were the simple steps of how you can install on your IDE. But in this session, we are focusing on online simulator. Why? Because the session is online, and if using online simulator is a very good thing. But before going to the online simulator, I will also tell you that there exists one online IDE. Why to use this online IDE? Because in desktop IDE you can program it from your desktop. That's good, you can use your desktop, but everywhere, every place your desktop is not available. Maybe suppose you have built some application today, and after years or after some time only, because now the update are coming very frequently, so your system needs some updated version, so you need to do everything manually. So removing all these barrier, if you go for online ID, then it's best. So let me show you that how you can use the online IDE very easily. The same that is sketch, we will see the whole step here, so be with me. So what you need to do is simply in new tab you need to write Arduino cloud. Okay, and you need to click it here. Then this screen will appear in front of you where you need to do the sign in. So if you don't have an account, then create one. What you need to do is type your date of birth. Suppose your date of birth is 1st July and your year is 1990. Next. Here you need to enter your email ID. Mine is Salia Mariam .7@gmail.com. You need to choose a username. I choose a Salia, and you need to choose any good password. You need to tick all these things. You are a student, so you will choose this education one. Okay, so I have already registered with this account, so you need to proceed with this only, and I will use my Google. So let's take a tour of Arduino Cloud. Here you are. This is your home. This is from where you can take new sketch. I will just click on it and see. So this is the whole IDE on the cloud. So it's saying to upload a sketch via USB port, make sure the agent is installed and running on this. So up till now I have not added any device. So when you will connect any device, then only you can program here, and that program can be loaded on you. So it saves you from all that complexity of installing and then running on your own desktop. No need, just sign in and program your Arduino from any desktop. That's so easy. So far, we have explored two options on online IDE and desktop IDE. Both are preferable, both are good, but what people say and what is more popular is using the online ID because it comes with up-to-date version. You don't need to update it. It have sometime it gives you some new projects also in which you need to code very less. So all these things are there due to which online ID is more preferred than desktop ID. So So Arduino API can be divided into three main parts: functions, variable, and structure. Functions are used for controlling the Arduino board and performing some specific tasks like reading anything or sensing anything or giving command for any action. Variables are the Arduino constant, data types, and conversion into boolean array. All these variables are used similar to C. And in structure we can divide the Arduino program into two parts. One is the preparation part, another is the execution part. In preparation part we have the setup block, while in execution part we have this conditional statement and loop and all these things. Setup part is like important. Even if you have nothing, no statement to write, then also your program must have the setup block. Okay, in setup block what we generally do is we initialize our pin modes and start the serial communication. When the setup part is executed, then only our execution part will execute. This loop statement that you are seeing here, it's written, it's come into the execution part. Loop, as the name suggests, for repeating some task, we use this loop function. We can also initialize our own function in our programming to add more functions, no issue. Next is control structure. Here we can use this if, else, while, and for as we do in C. If is the conditional statement, while is the exit control conditional statement, and for is the loop conditional statement. Okay. Arithmetic operator are multiplication, addition, subtraction. All these we can use. All these things. Remember, all these things we are using in execution part, and in preparation part only our setup block will come. Okay. Further is the comparison operator such as double is equal to check the condition whether that one condition is equal to other or not. Exclamation mark equal to refers to the not equal to. Suppose we need to satisfy any condition where the first condition is not equal to the second condition, and the last sign is for the greater than. The Arduino API can be described as simplification of C++ programming language with lot of addition or controlling the hardware. Okay. As in previous slide, I have told you that minimum requirement of Arduino program is the use of these two functions, void setup and void loop. Void is used in C programming also when we don't return anything from that function return doesn't return anything, then we use void. Same thing is with this Arduino programming structure also, that void indicate that nothing is returned on the execution. Void setup, what it does, it initialize the mode of pin and it starts, or you can say initialize the serial communication. Void loop, there is where we write the code that we want to execute again and again and again, such as turning on off of a lamp based on the input, or to conduct a sensor reading every X second, or to give any output after every time, or to trigger any action after every period of time. So all these things we define in the loop function. These functions are always required in Arduino sketch, but apart from this you can define your own function. For example, you want to calculate the factorial of some value and then you want to reflect it back. So for factorial function you can define, and then in loop function you can call that again and again, and it will give you the value again and again. This was just an example that how you can use other function also in your Arduino programming structure. You will get more insight of programming structure when we will do the hands on in the next lecture, and when you will simulate your own Arduino board and you will program it, then you will have a good insight of this. So here we have discussed only the basic of Arduino programming. That's enough. Now we will move on the application of Arduino in our real life, you can say, or you can say the state of art. Okay. Arduino IoT Cloud is one of the emerging application of Arduino board, as it is helping us to build a connected object in a quick, easy and secure way. Arduino IoT Cloud is enabling nowadays to breathe digital transformation in our real life. It actually gives an easy and less code approach to the programming, as it gives the multiple projects and makes the complex application very easy. It gives the feature of onboard programming. Onboard programming means, uh, suppose you are somewhere else and you need to program your IoT environment, or you need to make some modification in your already IoT program. So you don't need to be there and you don't need to be at the site only to program with your Arduino cloud. In Arduino IoT cloud, it gives you the best way to do this on board. The plug and play onboarding that automatically generates sketch, yet is the one of the most feature that are being appreciated of this now. And easily and remotely you can manage your data. Suppose you have put some monitoring system in your home, so from the remote place you can monitor and check your data and assess your data, or according to those data, if you need to give some action or command to your IoT devices present at the site, so you can do this. All these things are IoT is enabling you. Arduino IoT cloud is fully integrated in the Arduino create ecosystem. You will be able to generate template code in Arduino IoT cloud and then edit and upload it to your board using the Arduino web editor. It have this application of Arduino have made the life simple, very simple. Why? Because the complexity of programming or the constant of staying at the site and then doing programming your Arduino have been removed. All these barriers have been removed. So it's very much very much easier, very much fluid and good to go. So let's move to the next application. Nowadays, smart home automation is one of the thing that we listen in every day of our life. It has gained a very much popularity of this. Why? The point come here that why we are listening this Arduino based smart home automation tool. There are many things. One of the thing is security. Yes, it suppose you have installed your biometric system in your home, that when you give your thumbprint, then only the light of your home opens or the door of your home open. So this have made your home secure from the thief and robber. Another point is energy efficiency. Many times this happen with us, that when we are far away from our home, then useless thing that we have forgotten with our human mind, or in useless thing that uh, energy is being wasted. So it's saving the energy. It's sensing that whether there is nobody at home, then the energy is saved, the extra lights, fan and bulbs are getting turned on. Next is saving in the sense, yes, your money is saving. Why? Because in once you have installed this home automation system, so only at the needful time only your dishwasher will run, only at the needful time your washing machine will run, for the needful amount of time your AC will be turned on and then it will be off. So yes, it is saving also. It have bring the convenience. Of course, home automation was only aimed for the comfort purpose only, so it have brought much more confusion. So this is an application of Arduino to automate the control of all the electronic devices. That's what I was telling about you, that how they are benefiting the society and why this have became so much good. But apart from this, some cons are also there, like intelligence is very expensive. The intelligent system that you are installing for smart home automation cannot be afforded by everyone. The technology learning curve, because in home automation system what happened, that slowly and slowly and gradually your system will learn your habit, your behavior, and according to that things will be managed. So at some point this technology curve can saturate and this can create some problem. So all these things are there. What there from that, let's see that what more smart home automation we can get. Like the sensor can sense the intensity of light, temperature, and fire. The buzzer will beep when there will be change detected inside the house. When and one more thing is there that is not mentioned here is, suppose you are not at home, which generally happen nowadays, not at home, and you reach at 4 and the whole house is so much heated with the heat of the whole day, trapped inside it, that it become the greenhouse. So in smart home automation what it does, that it have recorded the time of your arrival. So before your arrival it will turn on the AC and will maintain the temperature of your room, and when you will reach your home, welcome to the heaven, all that feeling will come. So all these things are automated in the smart home automation. So let's move to the next application. So there are is endless list of Arduino based project, but for your understanding, for motivating you, I have listed some very good projects of Arduino here. So we will see one by one and discuss about it very detail as much we can do. So first application discussed here is a smart energy meter using GSM. So what basically happened is, many time our meter billing system having some error. So here we have a smart energy meter which capture the energy usage from your devices, and using the GSM modem it sends the alert on your phone that this much energy have been, I mean this unit of energy have been utilized. It take the record of it, calculate the unit, and then displays the reading on your phone. So this is a very good one of the application. Here you can keep track of your energy meter, means electricity meter, all the time through your alert on your phone. Another one is CNC machine using Arduino. CNC stand for computerized numerical control machine. Actually, this machine is for drawing any image or any 3D design or anything that was used. So this also can be built using Arduino. What all you need is three axes separated at 90 degree, and this is connected with the control. So when any design is fed as a program to the Arduino board, and it takes that program, it interprets the coordinate on the computer interprets the coordinate and that send it to the Arduino board, and according to those coordinate it positions its axis, and then the motor runs and the image has been drawn. So this is also a very good example, one of in on the Arduino based projects. Now the next example is GPS and GSM based tracker. This is specifically for the vehicle tracking system. In this, what happened, on your mobile phone you will get the location of your vehicle along with the Google Map location. There is two-way GPS communication. It uses a GSM modem and 2G SIM for communicating with your mobile phone, and it gives the location of your vehicle. It's very cheaper. Nowadays vehicle tracking systems are coming very expensive. So you can take this project and you can build a vehicle tracking system for your own vehicle. Also you can hide on your vehicle anywhere. So whenever you suppose, I just suppose this, suppose you forget that where you have parked your vehicle, and then you want it to track it and know that where it is. So you, this GPS and GCM will let you to do that. Next is a smart touchless soap dispenser. Smart touchless soap dispenser will sense your hand, and as soon as you keep your hand under that soap dispenser, it will give you that. Tweet a pot. This example I have given you earlier also. Let me explain you once again. In Twitter pot, what happened? A coffee pot is connected with Arduino, and Arduino is connected with a computer, on which from a mobile phone a person sends a tweet from his mobile phone. Basically, he tweet to his pot that prepare me a coffee. I will have a, and then he sent that tweet. That tweet is received, interpreted, and the instruction is being given to the coffee pot to process the coffee. Then he tweet that stop when done. Okay, stop when done. So now the through the tweet the instruction have came, and this will pass to the coffee pot that as soon as it will be done, it will be stopped. Now when the man reaches the his room, the coffee is ready, sir. So this is also a very good example of Twitter bot and very popular. Next is IoT using Arduino. This is the main purpose of our WAC here. We are reading the Internet of Things, and in that we are seeing that how Arduino, what is Arduino and how Arduino can be used and what Arduino based projects are there. So in IoT using Arduino, you can do the weather monitoring. Suppose you are at some place where, or at your place the weather is unpredictable. Let's say that weather is unpredictable. Anytime it can rain, anytime it can be sun, anytime it can be windy. Let's consider three. So you want that when it rains, then the light turns on, the darkness is gone, and when there is windy, the AC gets off, and you got a proper ventilation, means your window opens, sliding window just open automatically and a good air come inside. And when it's sunny, then your AC has been turned on before you're arriving to the home, so that house should not be heat up, and when you reach home then it's very cool down. So all these things of IoT you can automate using Arduino. In weather monitoring system, what it will do, it will sense the temperature, air speed, and the humidity. Using these three windows and the rainfall, it will monitor that what weather is there, and according to that weather it will send the instruction to the board, and the Arduino board will control all the devices and they can be used. So this is a very good example, one can try this also. So let's summarize our whole lecture now. What up till now we have read and what the session we have seen, that Arduino is a great choice and simple to use. Yes, when you will do the hands-on in next lecture, there you will see that how easily you can do just drag and drop things, and just you need to grab and connect the circuit and you good to go. But before that, as we have seen in course prerequisite, you need to have that electrical and electronic devices knowledge, because in this you need to know that which node is negative, which node is positive, which wire you have to connect where. All these things, electrical component knowledge is essential here. See, again I am saying that it is essential, but you can say desirable to it also, because your Arduino interface will only guide you that you need to connect this pin with this pin with this, and this will work very easily. So it's very simple to use. It is best tool to automate ideas. In last point of the application, how I have given you that weather monitoring idea, like that you can automate any idea. You may be having many, while listening all these lecture, many ideas have been inculcated in your mind, and you have been thinking that whether I can automate this idea also. Yes, you can. Arduino is very flexible. You can automate your idea very properly. Next, we have seen the anatomy of Arduino board. We have seen the whole block diagram of the Arduino board, and we have seen that how this Arduino, you know, have all the tiny things on a single board. Means you are getting the whole tiny computer on a board, which you can use for such a good purpose. Arduino IDE and program structure. We have, after that we have seen that how the programming structure of Arduino looks, where you can program your thing. I have also told you in Arduino IDE that whether you can use the online IDE and desktop IDE, any of them, and all these things. Programming structure, if it's not clear to you, don't take tension. In next lecture we will surely have a hands-on where we'll start with some simple programming, and we will move to some more, not, I will not say complex, but more complex programming language. Okay, so last point is the state of the art. We have discussed so many applications. One first we have discussed the Arduino IoT cloud. Why we have discussed in the application? Because it provides, it does very less code approach, and it's the application of Arduino, because it gives us very much flexible things, and it optimizes our code and execute it properly. So Arduino it. Next we have discussed the smart home automation. In smart home automation, I have told you the that how we can make our home more secure, more convenient, more comfortable, and there were some cons also, like it was not so cheaper, it's a little bit expensive, but we can see whatever is manageable. So after that we have seen 4 5 more application, like CNC machine using Arduino, and that GSM and GPS based tracker to track our vehicle. We can track our vehicle, and we can get even the Google map on your mobile through this Arduino board. See what a wonderful thing are there. Next, we have discussed the smart energy meter. The smart energy meter can be used as any uh, can be used for saving the energy on your home. A smart touchless soap dispenser, which is popular. We have seen also in many malls and everywhere. Then I have told you that to it a pot, video, and the IoT Arduino, using Arduino. So this was all about the on Arduino hands-on. I'm Salya Miriam here, back again with the VAC Days 8 hands-on tutorial on Arduino. Today we will do some activities on Arduino using the online simulator. So let's see what we will learn in today's session. In today's session, we will talk about Arduino IDE. In Arduino IDE, we will once again revise the whole
topic that we have discussed in previous overview session, that which online id, desktop id, how to install them, how to use them. Then we will move on the online simulator, that is tinkercad. We will see an introduction to tinkercad circuit simulation. Here we will know about it and we will get some information about it, and then we will start with tinkercad dashboard. As I have told you all before only, that you must have sign in beforehand so that you can go parallelly with me and use this tinkercad to design your prototype of your circuit. Then we will see that what components tinkercad provide us for prototyping our ideas, for automating our ideas, and how handy it is. And then we will do three activities. First, we will learn how to design a circuit. This we will do by just blinking an LED. Then we will, in first, our first activity will be of controlling LED brightness using potentiometer. Here we will use a potentiometer to control the brightness of LED. And in second activity, we will record the room temperature and visualize this data on things speed. This will be very helpful because when further you will design some complex project or some big projects, then you need to gather your data also on some type of channel. So activity 2 will be more interesting. Activity 1 will clarify your idea, and the first one activity, that is to design a circuit. Here you will start, this is the hello world program of your Arduino. Okay, so in our end note we will summarize all these activities, and in assignment I will give you one activity that you will do at the end. In previous lecture, we have learned about the anatomy of Arduino boards. Here we have seen the different structure of the board. So for quick revision, let's once again see the whole board for a quick time. So here is the Arduino block diagram in front of you, which we have seen in last lecture, that where are the input output ports, where are the where is the microcontroller, where is the USB sits, where we give the DC input output, and the power circuit, all this. Let's see the board also once for the quick. Here is the Uno board which you will be using for simulating your prototype in the Tinkercad. In this, you can see the reset button, your digital input output pin slots, in analog input output pin plot, and Atmega 328P microcontroller, which is the heart of the Uno board, and RSTS LED. These four status LEDs you need to focus while working on your Arduino board. One is this RSTS LEDs, built-in LED that is connected with 13, and the status pin, that is on, whether the board is on or off. For the input, the USB connector port is here, and DC barrel jack is for the power supply to your board. Okay, that was in a nutshell the whole Arduino board. Let's move forward further. Further, we have learned about the Arduino IDE and programming structure. In Arduino IDE, we have seen that how one can install the Arduino on different platform like Mac OS, Windows, and Linux. And also we have seen that how you can use online IDE, as well as you can also download your own desktop IDE and program your hardware. In programming structure, we have seen that two programming there are two part. One is the execution part, one is the preparation part. Both part are important in programming structure. One is setup part, and the other one is loop part. The main purpose of setup part is to initialize the variable, pin modes, start libraries, and the setup function will run always once after the each power up or reset of the board. The second part is the loop part. The main purpose of to control actively the Arduino board. As the name suggests, it does the constructively, it do a task repeatedly to make some changes or some control some task assigned by the user. Uh, loop part is always executed after the setup part, even if you are not executing any code block, but you will always execute the setup part. After this, we have seen the real world Arduino projects, next like smart meter using GSM, CNC machine, and many more projects such as Toyota Pod, smart home automation, and IoT cloud application in Arduino based projects, all these things. So this was all about the previous lecture that we have done a quick revision. Now we will move further to today's lecture, as we are going to work on an online simulator. On this online simulator, what we will do, we will exactly use the same hardware that we will use in our real life projects, and we will exactly use the same type of code that we will use in the live course. So before moving further to online simulator, let us revise Arduino IDE a little more in detail version. The Arduino software consists of integrated development environment IDE and the core libraries. The core libraries are written in C and C++ and compiled using AVR GCC and AVR libc. So, as we have already seen that Arduino provides an IDE whose programming structure is same as C programming language. It is similar to C programming language, but not exactly C. It is much more easier than that. The Arduino software IDE allows you to write program and upload them to your board. On in online our ID, we have signed in a online IDE page, and we have seen that how it gives us the whole interface on our ubiquitous device. It's on the board, on the go like thing that you can from anywhere you can get the data, you can change the configuration of your settings and anything on the go, while as a desktop ID is for the offline purpose. If you want to deploy your Arduino project offline, then you can use the desktop ID. In previous lecture, we have seen both the way of using the online ID also, and we have also seen that how you can install the desktop ID for your hardware purpose. Now we will move further, and we will learn about the online simulator that we are today going to use. In the world of 3D modeling, Tinkercad has established itself as a worthy introduction to computer-aided design. Tinkercad has been popularized as a simplistic tool that can be used for building the prototype. This was first released in 2011 by software engineer Kai Bachman and Meko Moonen, with the goal of creating an accessible 3D design tool. In 2013, the site was acquired by Autodesk, the software company also responsible for other major CAD programs such as Fusion 360, AutoCAD, and all these things. And under this ownership only, the software has slowly expanded its following from young student to hobbyist and designer. For being free, Tinkercad already offer a ton of value, and as one of the first browser-based CAD software program, it also has some unique features that aren't always found in alternatives. This makes it a great all-around program that's suitable for most basic design application regardless of the users of which area one is. Okay, so the Tinker Circuit allows you to virtually create and program Arduino projects without the need of the physical hardware. This is the best point of the using this simulator. But why this only, that I have told you already. So this was all about the motivation behind using this Tinkercad online simulator. The goal of accessibility means that there are many helpful features on this Tinkercad website. The first is initiative simplistic interface. You can make the 3D model. Student can learn many modeling techniques and prototyping with Arduino boards using this. Uh, it's very fun also, you can say, to do the circuit type things on the simulator. without messing up in the wires physically. Now, for moving ahead, Tinkercad dashboard. Now we will log into there. We will see Tinkercad. You will be redirected to this page where you will see your name, the main dashboard area above this toolbar. Here, what you need to do is click on circuits, as you are going to design a circuit on Arduino board, and then you will click on create new circuit. Okay. So this is the whole dashboard. From here you can select any component. Suppose you want to see all the components, or you want to see any of these categories: component, basic, Arduino, microbit, and circuit assemblies. Let's see what component are here. In general, resistor, capacitor, polarized capacitor, diode, inductor are there. For input, push button, potentiometer, slide switch, photoresistor, IR sensor, all these are there. Temperature sensor. For output, LEDs, different type of LEDs are there. LED rings are there, the LED strips are there, and many more things, whatever you will need for prototyping your idea here. So what and this is the whole area. As in the slide we were seeing that we have two area, one is building area and one is programming area. So this white space which you are seeing, where you can click any of the component and bring there, this is the building area. So we will delete this. And apart this from, when you click on this code, here is the programming area. So when we will select any component and we will design, then you will have a more better understanding of it. And this start simulation is just like your online compiler, which will compile your whole code and then it will run to it. Okay, so let's move further. So let's see that how on this dashboard you can work further. You can here search your Arduino board, whichever board you need. Arduino Uno, Arduino Uno R3, or let's see how many board are there. Okay, two boards you have, Arduino Uno and Arduino Uno R3. Even for starters, you have these already designed circuits here. You can see, but let's don't get confused, we will start from the scratch only. So we will select this Arduino Uno R3, and you can put your Arduino Uno R3 anywhere on this. Okay, and here you can put your name, like suppose you can put it as my board. So this will be done. So in your code, now you can see that this block have been there, and if you don't want to see the block, you want to see the text, then you can see the text here. So automatically you are seeing that this dashboard is so much helpful to you that automatically as soon as you have inserted your board, it have written such a good program. All you need is to put the LED on which you are going to work, the output port on which you will pin mode will work, and all these things you need to enter here. Okay, so this is going to be very fun type thing. And from here you can suppose this is you have selected, from here you can delete it, this board, if you don't need it. And okay, so one more thing, here you can rename your project. Suppose you are going to do the first project, then you can name it as your first project, and whenever you will log in, then you will always see your first project there. Let's start with building with the Arduino board. For blinking an LED, the most simple one circuit. What you need to do is to type here Arduino, and here you will see that Arduino Uno RT. Place it on your dashboard very comfortably, and then you want an LED, as you need to blink the LED only. So I took this LED, I will place this here, and then and connect this cathode part to the ground pin of the board, and place a resistor here. This one, this will be connected to the anode of this LED, and this part will be connected to pin number 13. Okay, so this is the whole circuit, how you can connect an LED onto the pin number 13, and which is the built-in pin, which is status you can see here at L when you will on the board. This is also for debugging that whether the power supply is going in your board or not, and this wire is grounded to complete the circuit, as this resistor is the current limiting in, as our LED will work properly. So let's see how the code goes on. Here Arduino have automatically have built it its code. You can see that pin mode LED built-in output, and this here you can write the pin that you are using. You are using pin number 13. High means when the LED is on. 1000 delay is 1000 millisecond, means 1 second of delay, and then it will goes to low. Here you can put the pin number 30. Okay, now let's start the simulation and let's see what happens. See, you can clearly see that okay, this you can clearly see that this here you are getting the power supply from the USB. This is connected to your laptop, and this LED is blinking. When it goes high it turns on, and when it goes low turn on. Also check the status light. This on is showing that the power supply is going in the board. This is the built-in LED status that on pin 13 the power supply is going. So this is a debugging status LED here. So this was all about the how to blink an LED. Now we will move to the next activity. We will see that how you can control the brightness of an LED using the potentiometer. So again we will go on this for Arduino board and we will search here. Okay, then you see this Arduino tree and place it as you have done it before. Now you need an LED also connected as before, because of that only you are going to control the brightness. So we will connect in the same way as we have done before. Okay, I need a resistor. 'Kay. So up till now our LED has been connected here. Now what we need is potentiometer to increase or decrease the brightness of the your LED. So next one will change the color of the one. Let's say have a green one. 5 volt of supply we are giving to it, and then let's have a So this middle pin will go to the analog but where we are giving the value for changing the intensity of the LED. So this is all about the circuit here. And in this code, what we will do is we will take the text part here. Before void setup, we will initialize uh, a value that will take the sensor in. Here we will write int sensor value and initialize that as 0. Then in this pin mode, we will define the input and output way. So output we are already getting on our LED, so we will put here pin number 13, and here pin mode is where we have connected A0, comma input. Okay, yes. Then in this void loop, what we will do, we will input here that on which pin we are getting this high and low value, that is pin number 30 as defined before. And here in place of mentioning the millisecond, we will pass the value that we have got from the sensor. So here what happened, when you will pass this sensor value, this will take 0 directly. So to make our code so that it reads from the given analog pin, then we will redefine this sensor value in this loop block, as every time it will take the value of the new value of the potentiometer. Here we need to write analog read, and our pin number is A0. So this was all that we need to write here. You can see the blocks also from here, that what type of blocks, oh sorry, that have been lost. Okay, wait a second, I will write it again. So this was the whole code, and now we can start the simulation. First close this code and start the simulation. You can see that this is blinking at this lowest point after some delay. So when you move it right, when the value changes, now the speed of blinking has been changed. Means as you move this side, it will flicker more frequently, and when you move this side, it will flicker less frequently. Means at the greater value, it will explore the building area and programming area of Tinkercad dashboard. And we have also designed a circuit on blink and LED. Here you can very easily see the schematic diagram for circuit, how you have connected this pin number 13, and with that you have connected 220 ohm of resistor for limiting the current flowing through the LED, and then you have grounded it to complete the circuit. And here the user have used the breadboard also, where so when you will do on the that hardboard, then there you will surely need the breadboard to connect all these things very easily. This is the whole circuit of the potentiometer that you have used in your program. Here the user have with a 6 pin, you can connect with any pin and you can get the output. This is the circuit for the recording temperature and visualizing data on think speak. So here you can note down this whole circuit, and the code is provided to you. So far, we have seen an overview of Arduino. What is Arduino? Now you can explain anybody that what uh, Arduino you can do with Arduino. Why you want to learn Arduino? And Arduino ID we have learned using Tinkercad circuit simulation. uh, we have seen how the dashboard of Tinkercad look, what are the components on Tinkercad, what features it gives, how you can implement your Arduino project, and how easily you can code also your Arduino code using these online simulator. Then we have designed a circuit to blink an LED. Another activity that we have done, controlling LED brightness using potentiometer. And the last activity for recording the temperature. So all these were very good and very beginners topic on Arduino. Further, we will try to have more detailed, uh, more detailed and more depth back on Arduino, where we will learn more projects and and hope you all the best for your future session. Thank you.